All right, the virtuous cycle in machine learning and AI. Actually, there are multiple virtual cycles in this space. So today I'm going to talk about the one that I care about, which is the virtuous cycle between feature engineering and eval. Um, so, first of all, a virtuous cycle just refers to the idea of a process where the output of one event can positively reinforce the output of the next event in the sequence. And if you arrange these business processes correctly, then it can create a virtuous cycle whereby one process is continually reinforcing, force multiplying, and hardening the second process. So in this particular case, there's a very potent virtuous cycle that can be exploited between the feature engineering process and eval. Now, in machine learning, a feature is different than, say, a product feature. In machine learning, a feature would be a measurable property of a data set. And what data scientists do is they use features to drive model output. Now, on the other side, there's a separate process called evaluation. And eval is how you assess model performance. So the way that the system is supposed to work is that you eval your model performance and then use the output of that eval to reinforce, strengthen, and potentially diagnose opportunities or problems that you might have on the feature side. So if you do a good job with feature engineering, the task cost and accuracy of eval should be a lot lower. If you do a good job with eval, then the quality and correctness of your features and data sets should be a lot higher. In other words, if you do a good job of correctly and cheaply driving model output, you will get better evaluation. With better evaluation, in other words, a more complete and accurate assessment of model performance, you can use that as a feedback into your feature definition process. So that sounds good, but in practice, eval is a very complex process. A mature delivery organization might be assessing 3 or 4 different versions of the same, say, RAG application. Well, why 3 or 4 versions? Well, you very likely will be testing different chunking strategies, embedding strategies, model strategies, maybe even different model versions. So rather than evaluate each shape of the deliverable serially, which is feasible but very inefficient. What most companies do to be able to multiplex more efficiently is they'll stand up multiple versions of the same app and evaluate them against each other. It's a concept similar to A/B testing, but a little bit more nuanced. So every time you do eval, you're creating a bunch of data. If you drop that data on the floor, then you're missing the opportunity to use it as an input into your features. So the challenge for most ML delivery organizations, AI delivery organizations, is how do you not drop that eval data on the floor? And furthermore, how do you learn from it in real time in sort of a streaming modality so that you can calibrate your model performance in real time? That is possible to do, but a little bit tricky. And there's some technical stuff that maybe I'll talk about later. But for now, the main thing that I want to sort of put out there is this virtuous cycle where feature engineering and eval are on opposite poles of a virtuous cycle. Building that virtuous cycle is probably the most important thing you can do from an ML ops perspective. And it's far more important than any specific tool selection. It doesn't really matter what platform you're on, what tools you're using. If you aren't getting this right, then you have problems. Namely, you will never be able to trust your model output, and you won't be able to trust your model output because you don't have a system for improving model performance. This virtuous cycle is the system for continuously, incrementally, and responsibly improving model performance so that you can deliver more value to your customers. So maybe next time I will talk a little bit about that architecture, but this is this is getting long, so let's call it a day.